Good morning. I'm back talking about web servers today, as you can see. It's actually one of the first lectures I did, and I haven't done it for a long time, so I'm pretty excited because I like this. It's like, I don't know, I think it feels a little more practical than yesterday. The request stuff's all right, but building web servers to me is pretty exciting because that's when we, I think, start to transition into this web developer phase, right, where we're actually building stuff, products for people. So before I get started, could someone share with me what they believe to be a web server, the definition of a web server? A definition of a web server. Maybe not the one, but a definition of a web server. Takes less pressure off, it takes pressure off you if you don't have to have the definition, right? So what's a definition of a web server? Did we read about them on the weekend at all? No? All right. So I've put this picture on here to kind of try and mislead you, because these look like web servers, but these are just hardware that servers could run on, right? So the idea that web servers, it's software. It's software that allows us to make connections to it, make requests to it. It'll send responses back, and it's not just it's not actually the hardware that we see when we see the data centers and all the flashing lights and stuff. Those aren't the web servers. Those are the machines the servers are running on. So this is important. First project coming up, project 2. You have about 3 or 4 days to work on TinyApp. The way Don put it, it's a culmination of everything you learned up until now. So it means you're going to have to use all of the things that you learned last week to build this application, right? So what are some of the things that we learned last week that we expect we might have to use while building TinyApp? Modules. Yeah, let's do. We could do some modules if you want, and you don't have to. That's the cool thing about modules, is it's kind of up to you. It's a really developer-decided way to organize your code, but we can use modules. That's a good idea. What else? Some real basic stuff. Sorry? Callbacks. Yeah, you're going to have to use callbacks. The way that we actually configure our endpoints, our routes, the paths that we can accept requests on, is by setting up an event handler. It says, when we receive a request for this path, call my function for me. There's a callback right there. And it takes a request and a response object. That would be the parameters passed in. So we'll definitely see an example of that today. Anything else? Yeah, objects for sure. With TinyApp, one of the main things, you're going to need to store the data that's being added to your website that you're tracking, these URLs that we're keeping track of. That's all going to happen in an object in memory. Unfortunate side effect of that is that we lose that data every time we restart the server, but it's actually just an easier way to deal with it. We'll start using databases in a couple weeks. But for now, we'll use an in-memory object, which will act like our database. Anything else? No? I mean, loops and all the logical stuff that you've done, all the conditions that you've done. We're going to have to use conditions in our code to make things happen based on whether or not a user's logged in or not. That's an important thing to know. And you might send data back differently if they're logged in or not, so we'll have to use conditions. So again, everything we kind of learned last week, we're going to try and apply that this week to build a web server. And the whole goal of this web server is to shorten URLs. We don't really need to do that anymore. Twitter has come a long way since 2008. It used to be the case that if I took a really long URL and I pasted it into my tweet, I no longer have any characters left to actually say what I want to say. So what you do is you take that URL, put it into a URL shortener, get a very short version of that, put that in your tweet, and have 100 characters left for your message, right? But it's a really great kind of sort of, I don't like to use the term simple, but I think the requirements are pretty straightforward, and it kind of tests a whole bunch of different things that we might need to use. So it's a good project for that. TinyApp is in not really any way tiny. It's probably one of the bigger projects that we work on, but it's exciting. We do authentication and cookies and all this kind of stuff this week. Okay, so talked a little bit about what a server is. I'm going to talk more about how we find servers online, how they're addressed, that kind of thing. We're going to do some examples where we build an app that handles requests using Node's HTTP library. Then we'll transition from that and try and build the same app using Express as a framework. So we're going to see a level of abstraction today. We're no longer going to be using that HTTP library directly. We're going to be using it through Express. And then we'll use something called embedded JS templates to create dynamic web pages, which is pretty exciting to me. So this is how we, and then at this point you'll be pretty set to start off that project. Cool? All right, so servers. There's lots of communication models that we can use within computing. One of the common ones is sort of this request-response pattern model, right? Where we have a client making a request to a server. That server does some stuff. In our case, it might be looks up some data in a database and then packages it as some JSON and sends it back. That could be the stuff that happens. In your case of TinyApp, when a new URL is added, you're going to take that URL, add it to your URL database, which is just a plain object, and then send the response back. So the stuff that happens, that's up to the developer. That's what makes our apps exciting. But the model that we use, the request response, is ubiquitous in web development. And so you can actually have a whole bunch of different servers running on the same piece of hardware. And so that's why we don't necessarily call those machines web servers, because they could also have databases on them. They could have game servers, FTP servers, mail servers. They could have all these different types of servers on them. And so the servers are the software running on that machine. And we need to be able to figure out how we can find that. And so if that machine is hooked up to a network, either Wi-Fi, most likely not if it's a server, most likely it's hardwired with like a gigabit or 10 gigabit connection these days, we need to be able to find that machine somewhere on the network. So there's this thing called IP, Internet Protocol. And it was and in the definition of the IP protocol, they had these 3 lines to sort of describe how we find these things online. And I thought they were actually pretty nice. So a name indicates what we seek. So we can think of lighthouselabs.ca or any domain, google.com, whatever it is, anything that you've put into your browser, that is not actually the address to that site. It is just a way that we can do a lookup for that address, right? So the name indicates what we seek. We make a lookup to a type of server called the domain name server. Is anybody not familiar with a DNS or a domain name server? It has a record of domains, and we can we say we want lighthouselabs.ca. Okay, that's it. And then it gives us the IP address back. We can lighthouselabs.ca. Put that in there, I guess. So when I make the request to lighthouselabs.ca, it does a DNS lookup, and what I get back is the actual address. And so it makes the request to this address instead of to the actual domain. Cool? Okay. So we've done that lookup. We get the address. The address indicates where it is, and so once we have the address for that, we can actually find it on the network. We can make a connection to it. And then, but we don't connect directly to that server. We don't connect directly to that software or to that IP. We do it through a whole bunch of other servers and routers and basically the internet, right? And so the route indicates how we get there. And I can take, in my network utils here, there's a tool called traceroute here. And I'm going to take this URL, pop in here and see that these are the different hops to get to that server, that I can trace the route, or I can find the route to that server, and that indicates actually the path to it. So 3 things are important here when we're dealing with the web: the name, the address, and the route. But I said that we can run multiple servers on the same machine. And so if I'm trying to make a connection to a server, how does it know that I'm trying to connect to the web server if I just have the address? Or how does it know I'm trying to connect to the game server or the mail server or whatever other server is running on there? If I have multiple servers, how does it know which one? Port. Yes, exactly. So we use a port. And so this is sort of the last step. This is, I guess, if the address is actually sort of the where the building is, then maybe there's 3 or 4 apartments in there, and the port is the actual the apartment that you want to get to. So you might have to drill down a little bit more. A port, again, allows us to run multiple servers on the same piece of hardware. I want to point out that any port that is below 1024, the number, right, it can only be opened up by super user accounts. So sometimes you want to open that port, a higher level port, I guess. So anything between 1024 and 65535. This is why we use 3000. This is why we use 8080. This is why we use 5000. Is because it's above that super user range, and just regular accounts can create these ports. Normally, what happens though, when we deploy this server for people to use and on the web, we want to have our HTTP server running on port 80 and our HTTPS server running on 443. Chances are we really just want 443 these days. We don't want an unsecure version of our site. But these ports are both below that, within that super user range, and so you'd need administrative rights to be able to open up these ports. Okay. Make sense? So when we develop, we use port 3000 or any port that we want. But when we deploy it, we will open up port 80 for connections, or 443. All right. So I'm saying web server. Technically, what we'll build today is a web server. And there are also sort of like commercial grade and high quality open source projects out there that provide to us web servers. These three are the most popular out there today. Has anyone not heard of Apache? Okay, so this is sort of web was built on Apache. All the WordPress sites, all the PHP and all that from early days made Apache super strong. So they're first. These days, though, Nginx is kind of catching up. This is the one I use. And it serves a couple different purposes. I can do some load balancing. So that means I could have it take in a request, but then pass it off to one of many servers if I needed to reduce the workload on maybe one of my servers. So Nginx is pretty sweet. It's slowly gaining on Apache. And then what about IIS? Is that familiar to anyone? IIS? Okay. So if there's a third, so if Apache and Nginx are not really, they're not maintained or created by a large company, but IIS is from a large company. Okay. So anything that's running on the Microsoft tech stack, .NET, for example, might use IIS as the web server. So this is Internet Information Services. This would run on Windows, and this would be Microsoft's web server. So that's why it's third, is because they are the behemoth, right? And so they have a lot of their code out there. All right. So you don't need to understand this right now. It's possible I bring this back in week 8 or week 9, and you're like, okay, now that makes some sense to me. But I just want to kind of show you that we could have a Ruby on Rails application, a Node application, and a PHP application all running on the same piece of hardware. We can give them different ports or even use a local kind of socket connection if we needed to. And at the end of the day, we might receive a connection on port 80 and route that traffic to the web server that needed. So let's say that Ruby on Rails is our web compass. So it's webcompass.lighthouselabs.ca. And Node, our Node app, or whatever, is the actual lighthouselabs.ca website. So you've got two servers, one for Web Compass, one for the marketing site. Both run on the same server. They have different addresses, right? They have different names, actually, but the same address. So one of the names would be lighthouselabs.ca, and one of them would be webcompass.lighthouselabs.ca. We can use Nginx to take a look at the name that was used to make the request, and then route that traffic to one of the servers that's running on that machine. So even though all connections are coming in on port 80, because those connections have different host names, we can route the traffic to different servers on our machine. Like I said, you don't need to learn this right now, because today, all we care about is this piece right here. That's what we're building right now. And eventually, by the end of this, you will, not today, but by the end of the boot camp, hopefully how it fits within the whole infrastructure makes more sense. Cool? I've definitely brought this slide back in a later week when I was explaining how to deploy software to a server. And I think it made more sense to people at that point. Okay. So let's do some requests with Node. And this is just the built-in Node HTTP library. So I'm going to start from absolute scratch here. Well, not absolute. I'm working in Node. I'm not working from scratch at any point in time, because I've got this great library to work with, and I can install all these modules. But my directory is empty. This is what we'll see. So LA, nothing in there. ls-la that's just shorthand for that. So there's nothing in here. I'm going to start by initializing my project. If I do it this way, then it's going to ask me a whole bunch of questions. I'm not in the mood to answer any questions, so I'll say -y, and it just built my thing for me. Okay, good. So now, take a look at this, and I've got a package.json. Good. So I've started off my project, and what I want to do is create my first file, which is going to be node.js, or let's say node http.js. Okay. Now, got this thing going on. The first thing that I need to do is identify what my dependencies are. And the only dependency I believe I will have for this specific project right now is that HTTP library. So I'm going to start by requiring HTTP. So now I have access to this, and I'm a little bit lost, so maybe I should go take a look at the node documentation. Get rid of this for now. And in the docs, again, we talked about, I'm going to go into the version that I want, so node-v. I'm at 8.11. So head back to here and grab the HTTP docs. Okay. There's actually something in here that I know about already called create server. And so create server is going to be, we used HTTP to make requests yesterday. Other side will be to create servers. And so I'm going to set this up here. So I just take this code, create server, make sure I write that properly. And I can say http.createServer here. And this takes in 2 optional parameters, although I can't imagine what use my server would be without, I don't know, a request listener at least, something that I can use to handle those requests. So I'm really kind of, for all of you, I'm really not happy about the node documentation, because it does things like this. Like, what does this mean? Now I have to go over here and read what okay. And then, readable stream, I got to know what that, so these documents are pretty tough to get for newer developers, I find. So again, that's why we do the lectures, that's why we try and explain this stuff and go through it. So what I want to do here is actually take a peek at sort of the code that I've put together here. And so this create server call, it said that options was optional, and it said that request listener was optional. And what's actually kind of interesting about it is if I do not pass it options, then the first parameter becomes what we see as the second parameter, the request listener. So that's what I've done here. I've just passed a single parameter to create server, and that single function that I'm passing to it is the request listener. I'm not setting up any special options for this, okay? So this is a function that takes in a request and a response object. And eventually what needs to happen is we have to say response.end. And this is what will complete the request. So what's happening here, we create the server, and we create the server. Every single time this server accepts an HTTP request, it will call this function here, providing us access to that request, and expecting that in order for it to finish and to get that response, that we will call response end. I'll call this a sort of finishing method or something like that, something that finishes off that response, that tells it that it's done, and Express sends it back to the person who made the request in the first place. If I don't have this, my server stalls. I sit in the browser with that request pending. I never get a response back. Just sits there, eventually times out. I don't know, the browser gives you a dinosaur or something like that. So we need to make sure we end all responses we need to end all of our responses. We can't have any code paths. Like, if this, send the response back, else do nothing, or else do something that's not sending the response back. In that case, there's only one code path, sends a response back. In the other case, the user just sits there hanging. So we have to be a little bit careful of that. In addition, with this server that we've created, we're going to call the listen method. So we're going to tell the server to start listening. We can give it a port and a host name. I'm just going to actually declare those variables up here. Oops. So these will be the port and host name that I use to listen on my server. It needs the port and the host name. And then actually we have a third parameter, which is a callback that will just tell us that the server is listening. So it's actually usually not bad practice to console log here something like server listening on port plus. Yeah, that's fine. Something like that. So this is actually kind of the basic. This is the minimum I need to make an HTTP request, I guess, I think. Let's see what happens if we end this with hello world. Oh, this is what I forgot to do. It's been that long. I'll just show you what this documentation, I want to show you, yeah, it's a little confusing. It doesn't really tell us what's going on in that function. But there's usually ways for us to figure out what's going on, and that would be through code examples. And so one of the great code examples of our time is right here. Node, it is so, HTTP is so important to Node that the Node hello world example is actually an HTTP server that responds with hello world. So ideally what I would have done is actually taken this, copied and pasted it in there, and then kind of walked you through it. But this is where we were going anyways. I will take, however, these pieces here. Actually, we'll build that up. That's fine. So response.end hello world. We can see that that was called right here. I will put the new line. It's a good reminder. And now I'm going to run this app. So now it's sitting there. Server listening on port 3000. We notice the app isn't shutting down. That's because it's listening. It can't shut down if it's going to continue to listen. So we'll say localhost 3000 and make the request, and we get hello world back. And if I say /about, we get hello world back. And if I say, doesn't matter, we get hello world back. And the reason that this is happening, it does not matter what our request is. We always send the same response back, right? Cool? So any questions about this so far? Yeah, please. Okay. So the create server call is purely software, and it's going to create an object that has some functions on it. For example, the way that we get this listen function is through the object that's created by create server. The purpose here is for us to give it the event handler that it will call every time it accepts a request, and then from that point on, we will create our logic inside of this event handler. We could actually break it out into different functions and then call those functions from within here. I will show that to you. But there is no hardware. There's no necessity for sort of virtualized hardware anything. It's all software accepting standard TCP connections on this port and host. And then those connections are intended to use HTTP, so we expect that it will send the request line, the headers, the body, and we'll have that information available to us in the request that the HTTP library provides. Cool? Yeah, that's good. Okay. So let's make this do a little bit more. You know what? I'm not going to use semicolons today. There we go. So I kind of want to maybe add a little bit more, because if I look at this response, and this is where we live, is in this network panel. Take a look at this. It's saying by default the status is 200 OK. That's fine with me, I guess. I could set some of that information. So remember, I'll bring this breakpoint back. Actually, I'll kill this server, bring the breakpoint back, kind of run this here. I think that'll work. Good. Make my request. The response here that I have access, or I think it's the response. I want to set, maybe I want to set the, what's it called, status code. I could do that. There's a whole bunch of, see here, we got the status code. What else? I could set headers if I wanted to. And so that's what this kind of looks like here. they're setting the status code to 200, although we know that happens by default. And then they're also setting a header here called content type and saying that the text is plain. So we can do the same kind of thing. Response.status code is equal to 200, and response.setHeader is, the key is going to be content type, and I believe the value is text plain. So now when I run this, we make our request. Yeah, I don't know, it says text plain here. Could change this to HTML. Put some HTML on it. Then restart the server, because now my server has changed, so I have to do that. Then head back over. And now it's HTML, and I can see that it sent that it was HTML. And then it's actually bigger. It's a bigger message now, because I had to put those 8 extra characters in for H1 close, or I guess that's even more. It's 9 extra characters, because the close tag. So this is sort of the basic server, but it doesn't really do much, right? What we want to do is sort of conditional logic based on the path. If you make a request to /, I'll give you the index page. If you make a request to / about, I will tell you about the people that made this website or whatever. / contacts, I'll give you a contact form. But there's different logic based on the path. And so we might start to think about how we write that if the, well, let's look at the request first before we start making any guesses as to what's available on it. We can look in the documentation. I like the debugger. It kind of tells me, I can, oops, let's get this running as I say that. Did I get rid of that line too? Yeah, there we go. What are you doing? No problem. I didn't actually say that to you, I hope. I'm talking to the code. And I lost my train. Okay, so let's see. Why are you not stopping there? Node. Oh, there's my error. Thank you. Okay. Oh, address is in use. So I got to read my errors. I got to close my server. That's what was happening. I run this now. Come on. Much better. Server listing on port 3000. So what I'm going to do is I'm going to make that request. And I'm going to make that request to class definition, the destination of this thing, whatever. And the reason I did that is I want it to be very obvious what this path is. And so as I look through, this is the request that was passed to me, right? So in this function here, in this function, I have 2 objects, request and response. The request comes in, and I want the response to go back out. And so I can grab information from the request to determine what the method is, what the path is, right? Those are the important things. Based on the method and the path, I can then determine how I want to route this traffic, this request. And I can set up a response that it takes, I guess, all of the data that I want, and it sends it back to them. So, and I can tell them what the status code is. Like if we didn't find something, I could set it to 404. I could put a message that says not found. I can configure that. So it's the response object, or the request object that we need to look into to kind of see what's going on in here. We've got the HTTP version. We've got a method here, so I can say request.method, and it would tell me that it is the get method. I can say request.url, and sure enough, there it tells me that it's what the path is that was used to make the request. So here, I would start to do some conditional logic. I might say if the request.url is equal to just a /, then we want to send back this thing here, and we'll call it, we won't say hello world anymore. We'll just call this the root or index, whatever we want to call it. But just here is the root of our page, and I save this, and I'm so excited to run it. And I do that, and I go over here, and I go to my root path. It's like, yes, that's what I expected. And then I go to my about page, and I am sitting there, oops, waiting for localhost. I hope you can see that. Let's see. See this waiting for localhost? Why is that happening? Why didn't I get any? Why? That's right. So I've sort of broken it by saying, by having only a single code path that sends that response back. And so maybe I say, well, if it's anything else, then I'll take this here and I will send back a 404 that says not found. Okay, so now I have both code paths satisfied, and both of them send a response back, so no one should hang on this site anymore. Oops. Restart my server, head back over, make the request to /, that's all good. / about, not found, not found. And so I'm getting back a status code that represents that that resource is not there, that path does not exist, right? Okay. Well, so I might say then else if request.url is equal to / about, then we will take this response. Actually, I want this one up here because it's 200. And I want to say about. Okay. Start the server, head back over. Nothing there. Take a look. We get the index, that's good, and then / about, and we get the about page. So I've done some very basic routing here, but you can imagine how hard this would get to manage, right? If I just wrote all of this in one function. So let's look at a little bit how I believe, or how I think of it when Express does this, because Express provides a slightly different interface for us. Express allows us to define the route that we're interested in and the request handler for that route. And at the end of the day, Express has this code in here, the create server stuff with this event handler. Express is using HTTP just like I am right now. It's just it's providing a nicer layer of abstraction over top, a nicer interface for us to use. And that interface might look a little bit like this, where we define our routes, maybe as an object. And this route /, that's our index, it has a function in here, request response. And that is just, this is what it does. So when we receive a request to /, make it call this function. When we receive a request to / about, then make it call this other function here. Right? So now I've started to break out the logic for the routes into their own functions, and this is the direction we want to be going in. So now my logic is a little bit different, right? I've got to check to see if this request URL is in this routes object, right? And if it's in this routes object, then I will pass the request and the response to the function, and I will invoke it, and it will send the response back. And if it is not in that object, then I want it to send back a 404 not found. So how do I determine whether or not a value is in an object? We did this last week, right? Like I said, a culmination of everything we've learned so far. We're even using patterns that we learned last week. There's many ways to do it. If routes has own property request.url, okay? So if the request URL is /, does it have the property /? Yes, it does. Good, we'll call that function. If it has the property about, good, we'll call it function. Anything else, it does not have that, we get false back, and we do a 404 not found. Cool? So if it finds it, routes request.url, call this as a function. Is this confusing for anyone what I just did? I'm calling this as a function here, passing the request and response in. This, when it does its lookup, gives me a function. So I invoke that function, passing the request and the response. Now, when I run this server, I should still be able to go to / get root index, about. I will get the about page. And let's add one more just for fun. Dreams. And I will support this by putting in so now I've not started my restarted my server. If I go to the /dreams not found, I will restart my server and I will go again, and then I get that as my response. So I was able to add a route pretty easily there by just defining what the path was to that route and what the function that I wanted to call here. Cool? Okay. So let's see. Just make sure that that's what I wanted to cover fully before we take a break. So does that look like this? Yeah. Pretty close. I did this like kind of little errors object instead with maybe a few of my errors. If I want to handle different kinds of errors, I could just have the code to handle those errors in their own function. So here, error 404, it's calling it. But I think this is, other than kind of some of the syntax here, which we might not be as familiar with, but we will learn all about that this afternoon. I've sort of avoided using it this morning. Most people are ready for it now. I mean, do you think I should just use arrow functions instead? No? Okay, well, we'll talk about it this afternoon, then I'll use them after that. All right, let's, I know it's early. If there are no questions, it's probably good to take a break before I move into the next phase, which is where we build the same thing using Express instead. And then we'll start building some HTML pages so that our HTML is not just sort of embedded in our end function here. That's not good. We want it to be in files that get loaded, and then those files get parsed. JavaScript gets run in them. Dynamically, they build the HTML, and we send that back in our response. That's where we will end up today. Who's with me? Who's coming with me? I think you all are. You have no choice. Take a break. I'll be back. let's get back to it. So we spent the morning talking about web servers, talking about Node apps, and then also the HTTP library. And I promised this afternoon we would, or I guess this next part of it, we'd talk about Express. And so we're going to be using the Express framework to do pretty much the same thing as we did earlier on. Express JS. Head off over there. And this is Express's page. Express has not changed much lately, and that's a good thing. It's stable. It's well used. It's a good piece of software. So here they're saying Express 4.16.0 and above, I guess, would contain that this contains security updates. So we still might want to upgrade it if we're on an older version. But I actually don't remember. I don't know when this actually was released. It looks like October. So the last release was October 10th. And the release before that looks like it was March 12th. That's actually a pretty big gap between minor releases like this. So it looks like they're really just fixing security issues that would come up. OK. We look at getting started here. They've got a hello world. We click on that. And here's their hello world. This would do essentially the same thing as what we saw in our other hello world. I'm going to create a new file here. Let's call it Express. Yes. I'm going to just paste that example in here. Now, they're using some new features of JavaScript, which I'll just manually transpile. Well, not necessarily, but you know what I mean. Function. Once I copy code into my project, that is my code. I need to make it like my code. I need to go through and make it like the rest of my code. I don't just copy random pieces of code from Stack Overflow that have different style than my code, pop them in there and say that's good enough. I would then refactor that code to fit the style so that I'm consistent. No semicolons there. We'll switch all these over to functions because we're not using ES6 until this afternoon. And so now this is more like my code, although I like to use the full words here. So even though it's more typing, now I can kind of tell that now I know it's a response, not a resolution, right? Let's run this. Let's see what happens. Oops. Of course. Forgot the most important part if we're using a library like this. I need to npm install that. So I npm install Express. That's what this is telling me. Can't find this module. Now when I run it, oh, actually, wait a second. That's why. Oh, I was wrong. The first error wasn't because I didn't install Express, but it reminded me I needed to install Express. The first error was actually because I did node run, which is usually the reason I made that mistake is because I usually type npm run and then some script that I want to run that's in my package.json. And so in this case, I kind of just went node run, which is not anything unless I have a script called run, I guess. But what I really want is express.js. So we run that, head on over to localhost 3000, and we get hello world. And I go to /about, and oh, that's interesting. It didn't just send me. It didn't just say, oh, yeah, I'll just send you the same hello world all the time. So that's actually a bit of an upgrade. The code doesn't look much different. I still have, I guess, these functionalities. But here, this app.get /, that's a lot like that routes object that I created. It's kind of just saying that this function maps to this method and path. And so I've only actually supported a single path. Therefore, everything else Express is going to assume is 404 not found. And that's why we got that cannot get /about with the 404 not found code, right? So we want to add another route to this. About. And in our response, we're going to send about. Now, you'll notice that this is response.send, not response.end. So Express is actually going to give us a number of different methods we can call that would, like end response would finish off the response. And at the end of the day, like I said, Express is just using HTTP. So at some point, Express is going to call end like we did. We just get a few more specific ways to do it. Send is going to be your general send some text. Just send some plain text content. That's fine. We've also got response.render. We're going to use that today to use when we use our templates. We'll have response.redirect, response.json. These are all different ways that we can finish off that response. Kind of cool is response.json might actually take, if we say var example equals, it's an object with some key name. So let's say I have this object. I want to send that as JSON. I can JSON the example object, and it's going to stringify it for me and then send that as stringified JSON across the network. So restart the server, head over to about, and there I actually got back a piece of JSON. We won't be using JSON this week for this project, but I just wanted to kind of show you that's how we'd get there. The methods you'll want to use this week are redirect, render, and I think those are the two main ones. Okay. I will restart the server. Now I get my about page. Okay. So is this kind of these routes here? The way that I've defined these handlers. Does this make sense? Yeah. There's a few things we want to notice as well. I could say app.get /posts /ID. I've just created a route that takes in a variable. That position for ID, what I want that to represent is actually the post of the ID that I'm interested in, right? So here I could say, I handle posts / something. In this case, we will assume it's an ID. And response.send request.params.id. So this is actually going to send back the ID that I put in there. I'll restart the server. Posts /362. And I have 362 here now. So I've just, the user, or maybe it's through a link or something like that, but from the client, we were told which post we're interested in. And within the server itself, we have access to that information right here. So this is how we start to get, we will do a database lookup maybe, say give me the post with this ID, and then we'll put that into some HTML and send that back. You'll definitely be using this. What happens if I want to create a path, says /posts /new. And what this route is, it's a route that would allow me to create a new post using a form, right? Response.send form, I don't know, input. If I go over to this site now, post new, here's my form. And if I try to go to posts 3, I get 3 back. What happens if I take this, put it down here? What is the difference between this and this here? As far as Express is concerned, it's just a position, right? So if I say /new, oh, restart that server. When I say post new now, I'm actually getting back the text new. So which route is it actually using? Which route is actually handling this? Yeah, it's this one. So what we notice is that the order actually kind of matters. That if we have a path that is that has a variable in it, we need to, or that matches sort of the pattern of something that we know to be sort of the full path, the hard-coded version, which is /new here. We want to make sure that new exists first, because it will actually find new and say, okay, I know what you meant by that. Whereas if it gives us the number 12, 12 as it doesn't match new, so it wouldn't use this route. It would fall through, and it would use this one instead, because these are essentially, it's essentially a stack it goes through. It says, is this it? Is this it? Is this it? Is this it? Oh, this is it right here. Here's our function. We'll call that and send the response back. Does that kind of make sense? You will have an opportunity to run into this issue yourselves with this project. And you know, if you do or don't, it's actually a good learning experience. But I thought I'd call it out since we have a little bit of extra time today because we started a bit earlier, or finished the first part earlier. So I will leave that there. Okay. Now, what else did we want to do here? So I've installed Express, handled my first route. Here we're doing listen. So let's look at that a little bit different. We're noticing I didn't have to pass the host name in. You can, but it's an optional parameter here. So that's sort of an example of Express maybe making it a little bit easier on us, writing a little bit less code. We'll see here that our app is actually an instance of an Express. We call Express here. It returns an object. That is our app. That app has get methods on it. We also have the ability to do app.post. So if I wanted to create a new post, I could do that. And when we make this request, chances are there's some data that's coming in on the body of the request. Well, if we installed the body parser middleware, which you will have an opportunity to do, then we could say post equals request.body dot, I don't know, subject. So we can actually access information that comes in on the body of a request through Express like this, but we would have to install something called the body parser middleware for this. I'm going to leave that as an exercise for you because we don't need it for this example today. But that's how we would access request.body. And that'd be data coming in on the form. Okay. All right. I will talk a little bit about middleware. I've said that word, so now we need to talk about it. This is one of the strengths of Express. This is actually one of the greatest benefits to using a framework like this, is the ability to hook in middleware. And middleware is sort of more just like general ways to handle requests that come in. And maybe you don't actually finish the response in middleware. Maybe you just tack on a little bit of data. Maybe you I don't know, reverse the string or set up a cookie. There's lots of things we can do in this. What I want to do here with middleware is I want to make it so that every single request to my site, when it goes through this middleware, it checks to see if there is a file that exists with that path. If there is a file with that path, I want to serve that file. This becomes very useful when we're serving maybe a directory full of images. So let's set up that example. Right now, if I wanted to, I could set up a public directory here. And inside my public directory, I might take, I don't know, a Lighthouse Labs image. Lighthouse Labs, images, Google, and then I want to go to images here, Lighthouse Labs. I just want something like this. Okay. Give me this image. Okay, web servers live, public directory, and I'm just going to take this image, this PNG image here, put it inside that directory, and call it lhl.png. Okay. So now I have lhl.png sitting inside of a public directory that's sitting next to my Express server. Okay. So now I want it so that when someone makes a request to this site, I send back the lhl.png image. Because web servers don't just serve plain text, they also can serve any types of files. So you might think, well, okay, if I'm going to handle that route, what I would be doing is Lighthouse or localhost 3000 / lhl.png here. And it can't get that because we have no route for that, right? Do I create a request handler for every single image that I have on my site? This sounds like an incredible waste of time, right? So this isn't going to work for us. We need a more general way to do this. And the general way is middleware. So what we'll do here, we'll use this Express middleware guide. Let's see here. Where is it? We want the static files. OK. So Express provides to us something called express.static. And what it does is to serve static files such as images, CSS files, JavaScript, use the Express static built-in middleware. And what this does, and this is the signature here, and what we need to do is set it up as middleware. So we're doing app.use. So instead of app.get or app.post, app.use is just general. Does not matter the method. It would still go through this route. Okay. So at the very top is usually where we put our middleware, app.use. And middleware takes a request, a response, and actually a function called next. The reason why we have this function called next is because we want to be able to inform Express that we're done handling this middleware, that we didn't send the response back, but that we want it to continue handling this route further down the stack. So this express.static here, which takes in the name of a folder, express.static takes in the name of a folder. We'll say this is our middleware. This what express.static returns is a function. This function signature happens to have request, response, and next. So we can take that middleware, request, and pass it along. Request, response, and next. And let's see how this works. Oops. It doesn't. We function this, run it. Okay. And now, when I make the request for that lhl.png, it's actually looking inside of the public directory. It finds that file, and then it sends that back in the response. And if I put a different file in here, let's say week2.png, can't find it. It's not in the static directory, but if I added that file into the static directory, it would now be we would now be able to access it through the path like this. So I kind of went around. I kind of did this sort of roundabout way of actually adding this Express middleware. We'll notice that our example here, they just passed this directly to app.use. Could someone tell me why that works? I can just, I'll actually show you the two pieces of code side by side. This function, this here, and this here do the same thing. I would only keep one in my project. The reason I'm showing it to you this way is because when I call static, it returns a function that takes request, response, and next. And it just so happens that when I call when I give a function to app.use, that function should take request, response, and next. Therefore, I can just pass the result of this call to app.use. It's going to be this function that takes request, response, and next already, and I don't have to do this sort of roundabout passing that in to the function. I know this might be a little bit overwhelming, but this is the introduction to middleware, and my recommendation is to look for some opportunities in your application to use middleware and refactor the application to use that middleware. So when you get to the end, if you have a little bit extra time, you're getting ready to submit, one of the areas that you might be able to use middleware in TinyApp is there's a requirement that at the top of every single page, we have the user's email address. And so instead of having every single route make that email address available, we could use middleware to do that instead. So that's your clue, that's your tip. You don't have to do it. I'm just saying that you could reduce the amount of code that you write if you switch some of your functionality into middleware. If you get to the end and you're not sure what I mean by that still, send me a message on Slack and I could help you get closer, right? But I would say that using middleware or writing your own middleware at the end is sort of a stretch goal for this project. Although I'm using it here, and this is sort of the most basic middleware that I know of that's provided by Express. There is a little bit of a write-up on this here for the middleware. One more thing I guess I should point out is that it's lighthouselabs.png here. It is not public/lighthouselabs.png. And this is important. Even though on my web server, it's in the public directory, it's actually what I give to this static middleware, it's ignoring the name of that directory, and it's saying that these things would exist at the root of the project. And the reason why we have this directory like this is because we want to make sure that only files that are in that directory, or the only files in that directory are ones that we want people to have access to. If we made this whole folder the public directory and just provided access to everything, then someone could type in, well, I guess if we say, I don't know if this will work. Never tried this before. Okay, so that doesn't work anymore. And if I say express.js, yeah. Because I made the public directory my root, people will now have access to my source code. It's not a good thing. So what I do is I create that public directory, I put everything in that, and then I make that accessible. But when we actually use the paths here, we would do no public directory in that. Okay? Express can't get it anymore, but we have lhl.png. Cool. All right. Now we're getting into EJS templates. So this is there's lots of different template libraries available that we can use with Express. Pug and I think maybe Jade, or I don't know. We can kind of look it up. I've never used any of the other ones really. Template engines. Here we go. No, that might be a little bit too much. Using template engines, this is what we want. So here it's saying that the supported template engines are here. Some popular template engines that work with Express are Pug, Mustache, and EJS. Pug has this kind of interesting syntax to it, where you might say, you might do something like this. So there's no like greater than less than symbols around our tags. There's no closing tags. We're not using that. Mustache is kind of, I don't know. Whoa. Huh. Never seen that before. Let's see what mustache might look like. So that's more mustachy. They call it mustache because of these things. These little curly braces, right? Similar to handlebars, I guess. Okay. What we're going to use is actually EJS. This one here is, I kind of like it. It's yeah, it's not bad. Pretty straightforward. Pretty limited feature set, but enough to do all the stuff we need to. So I would need to npm install EJS in order for this to work. And in my project here, I actually need to configure, I need to set the view engine to be EJS. I need to configure Express to use this EJS library as the view engine. So app.set view engine EJS. And this is where you would put pug or mustache or whatever if you wanted to use those libraries instead. I also need to now define where my views are, because we're going to split our views, our HTML, into their own files. And they're going to go into a directory at the root. We'll call it views. This happens to be the default directory, so I don't bother changing the name. But if you wanted to, I think it's just app.set view. Actually, I don't know for sure. I have to look at the documentation. I think it's just here. If we wanted to change where the templates are, it's views and then the directory of the views. I don't need to do that. Pretty good with just using that directory name here. So I'm going to put my first template file in there. We'll call it index.ejs. And my index.ejs is just going to have a little bit of index.html in it. Okay. Now I'll go back to Express. And instead of sending back this hello world, I'm going to actually render the index like so. So this is one of those methods. Like I said, you'll need to use render, you'll need to use redirect. Render, I provide it a parameter, and that parameter is going to be the name of the template file that I just created. Could be about.ejs, it could be index.ejs, whatever it is, I just put the name in here. So now, when I run my Express server again, and I go to the root path, I get the lowercase index HTML. And so now, what's kind of cool, you're going to notice, is as I change this, and I hit save, I'm not restarting my server. I refresh the browser, and I misspelled hello. But this is actually kind of interesting, right? I didn't restart the server because none of my server code changed. My EJS file changed, but every single time I make the request, it loads that file, and I get the latest version. So I don't have to restart the server for client changes or for EJS file changes like that, and that maybe helps a little bit with my workflow. So yeah, keep that in mind. If you are unsure, you can always restart every time. There is a little bit of a bonus section in my notes that talks about something called nodemon, which restarts your server automatically for you every change that you make. That's probably pretty useful. But I'll leave that up to you to investigate. So we've got this EJS template now. And just going to go back to this so we have full screen. Now I can start to, well, I'm going to take this HTML. I'm going to actually make this a proper HTML document. Go back. There's our index, has the title of index. And I want to start to maybe I want to make another one of these as well. I'm going to go into my views folder here, create an about.ejs file, paste in this about. And so now my Express server has to be updated as well. And I will render the about.ejs file. So run this again. I did have to change the server that time. I had to restart the server that time because I changed the server that time, even though it's EJS that I was primarily concerned about. And I go to about, and sure enough, I get back a nice response with a bunch of HTML in it. Okay. So this is how we've now separated our file, our HTML into their own files. And that is one great reason to use a templating library, is that we just kind of get that separation. The second thing, though, and likely the most important reason, is we need to maybe make some dynamic content that, based on the request that's made, maybe we want to show something different based on how that request is made. So I'm going to think about that in here. I want to show, let's say, I want to display to the user their user agent. So what I'm going to do is they're going to make a request, and one of the headers for that request is going to be the user agent. Okay. So they're telling me what their agent is. Could be Karl, could be Mozilla, could be Chrome, whatever. They'll tell me what that is. I will then have access to that information inside the request headers, right? So when I get that request, it's going to call my handler here. I will look in that request for the headers. I will check to see the user agent header, and I will take that, and then I will put that into my EJS file, and then that will get rendered back out as HTML, okay? So here we go. Request.headers. First thing I'm going to do is just kind of take a peek at the structure of this. So I guess what I should set up is my breakpoint. I will make my request to the root path. And I will look at the request here. Actually, I'll look at it over here. It's a little bit easier for us to see. And I'm going to jump down to the headers part here. And included in the headers is the user agent. So I could grab that information, which says Mozilla here, and make that available within my route. So I'll do that. Var agent equals request.headers user agent. Now I have to use this square bracket notation for this. Can anyone tell me why? What would this do for me? That's what JavaScript sees, right? So in a situation like this, I've been forced into using a character in my key that I don't really agree with. Like I tend to try and leave those dashes out of there so that I can use dot notation. But sometimes we're given no choice. Someone else is defining the key on an object. And so in that case, what we do is we wrap this up in a string so that it uses that dash as part of the string. And we end up with the access to it. OK, so there's our agent. Now what I need to do is make this agent available within my index.ejs file. I actually have the ability to, I think it's like, how is it? It's been so long. There it is, yeah. It just felt a little weird. So it's like this, and then I could put down maybe the agent, and then I close that off. So this is my special EJS tag right here. This is saying that I want to evaluate JavaScript within this part of this HTML file. So that's where we get the embedded JavaScript name from. Right? EJS, embedded JavaScript. There's my embedded JavaScript. But I need to make sure that this variable agent is available in the scope of this file. So there's one more step. There is a second parameter that we pass in that is an object that could have a key like this. So I'll actually just take that straight up. Do so. So now I'm passing an object to that template. Every single key inside of this object will be a variable that's available inside of that template. So now I've got a variable called agent available in that template. And I'll run my app. And now I will go here, and I will see that it is dynamically printing out the user agent. And if I take that same path here, and I say, come on, curl, I got different HTML back. Dynamic behavior. It's not hard-coded anymore. It's not static. So when you do your assignment, you're going to see this in a little bit of a different format. Var template vars is equal to some object, and then we pass template vars. Has this changed my code in any way? Like the behavior of my code in any way? No, right? So let's not get confused. Sometimes what I'll see is people will be doing this. But this won't work. because template vars does not exist inside the scope of this function. It was never passed in. It was just the name of the object that was used as the reference to pass in that object. So when we come over here, template vars is irrelevant to the index.ajs file. It does not care about any of that. What it cares about is this object and the things inside of it, and the agent is inside of that. So my preference is to actually just pass it directly, but that's up to you. Okay. About 50% of the time, I come over, sit down at someone's desk, and they've done template vars dot whatever inside their EJS file, and we have to remove that and then use the variable kind of properly. So that's not good. Okay. So we've done this dynamically. This is very basic. This is just we have some data from our route. We want to get that into our template. We actually have the ability to execute other JavaScript as well. For example, we can do for loops. We can do if conditions if we want, so we can have conditionals in there. What I want to do is set it up so that my web server here doesn't just list out the user agent header, but actually all of the headers and their keys and values. Okay? So for my Express server, I need to get that data into the template. And where that data exists is actually over here. It's the headers. So I'm not going to pass in agent anymore. I'm going to pass in something called headers. And headers is an object, right? We're OK with that? Yep. So I've passed this headers object into my EJS file. And here, if I just say headers, well, then I get this. So what I want to do is iterate through this object. And for each key, I want to put that onto the page. And then I want to put this value next to it. For var key in headers, or let's name that better, maybe for header in headers. So for each header. Now you're noticing that I've actually put this little symbol here, this little EJS start some JavaScript, and then I put one at the end. I need to also do the same down here for this little thing down here. And in between, what's going to happen, I'm going to start by creating my unordered list. I'm going to take my for loop, put that in here. And for each header, I will have a list item. And inside here, I will put the header. Make sure, restarted, get back to it. Here's my list of all the headers. And we can see that it dynamically generated all of the list items in here for me using EJS. That's what's happening right here. Is this making sense? Okay. So I want the header, then I want a colon, then I want the headers header. And what does this give me? The value of, yeah, exactly. So this is going to show me the key and the value next to each other. I didn't have to restart the server because I didn't change how the data is passed into the template. I just changed the template, so I should just see that change be affected here. And now, oops, we can see a list of all of our headers and their values. Okay. And if we had a list of tiny URLs to show, for example, and we pass in that list of tiny URLs to our template, we can iterate over that list of tiny URLs, maybe as a list item or a bunch of href tags or anchor tags if we want. You're going to have to definitely start doing this in TinyApp pretty quickly. I think that is all of, that's all of the content I had prepared. So if we have questions, I've got time for that. If you want me to go through more examples in detail, I can definitely do that. Otherwise, I don't know. It's up to you. How do we feel about this stuff? Do we just want to get to work, or do we want to continue playing with templates, or do we want to go back to doing some routes? Try it out? Cool, OK. Everyone feel good with that? OK, I'll send out these notes, and yeah, I'll be back this afternoon to talk about EJS. Well, I'll be mentoring, but I'll be in the EJS lecture, or the ES6 lecture, actually.